Sorry.
Okay. As I send a wave down there, the wave is moving that way, but each part of the slinky is moving out and then back. So its motion is perpendicular to the motion of the wave. This is transverse. Now the other thing we have going on here is that Giovanni has a fixed boundary, and when I send a wave down there, it hits the boundary and gets reflected back. Okay, which side does it come back on? The other side. Okay, it goes down there, hits, and comes back on the other side. Okay, so that's another thing we're going to talk about in a little bit is reflection. Okay. Okay, while we're doing this on a fixed boundary, this is how radar and sonar work. Okay, if I send out a sound wave and I know its velocity and frequency, and I time how long it takes for it to go hit something and come back, what can I figure out?
Its speed.
I know its speed and I know its time. Distance. So I can ping. Oh, there's the sub. If it's sonar or radar, you get a flip. Oh, there's the plane. And you know exactly how far away it is and you can tell where it is. Okay? All right. Now, compression waves are harder to show. Just hang on to that. I'm going to try to tighten this up. But see if you can't see them.
That's a really long slinky.
I'm trying to not get any transverse in it, but can you see how every place along is going back and forth this way, not this way?
Yeah.
It's hard to do without getting some motion this way. But compression or longitudinal waves, okay, see you can still see the waves go down and come back. But each part of the slinky is doing this, not this. Alright. Now, while we've got it out here, let's do interference, we'll talk about in a minute. Constructive and destructive interference. This time, he's going to send a wave too. So let's just send a wave. Alright, keep doing that. Just keep doing that. Okay, just keep doing that. Alright, now I can send another wave and look what happens when they meet.
They get straight.
Well, sometimes they get bigger. They have constructive interference, and sometimes they flatline each other. I want you to just keep doing it at a constant pace. And I'm just going to mess them up. I'm going to interfere.
Like a video game.
Okay, so you can see when they meet, something
It's calling
happens.
for physics.
If they get bigger, that's constructive interference. If it gets smaller, then that's destructive interference. Called superposition. Just keep going. So, two waves in the same place, superimposed on top of each other, are going to interfere with each other, one way or the other. Did I show you the Acura commercial? Okay, the Acura commercial. They use this principle. The frequency of the noise they want to get rid of, they pick it up on a microphone, and then they send out the opposing frequency that will destructively interfere with it and make it go away. That's beautiful. I don't know why they didn't think about that sooner.
Wait, what happens?
Okay.
What do they do with the waves?
Acura has microphones on the car that picks up unwanted engine noise that we don't want to hear. Okay? And then they send out an opposing frequency that will destructively interfere with it. So when those two waves are in the same place at the same time, they go away.
So,
out of our range of hearing, we don't hear them.
So in other words, you're driving your car and all you hear is, "Come at me, bro."
I'm not a bro.